Hello and welcome to the Crazy Hat Chemist. Here we go. Stoichiometry and dimensional analysis. Here again. We're doing 4.4 today. That is basic stoichiometry without balancing equations. So let's get moving. Bam! Okay, so number 4. It says, if a flask is filled with 30 with a decimal place, grams of chlorine gas, how many chlorine atoms are present? So first of all, what is the formula for chlorine gas? Chlorine is one of those special ones. Think about it. There's an L on your forehead. That should tell you that you're going to flip that down, and that's a number 7. And there are 7 diatomic elements, chlorine diatomic molecules. Chlorine is one of them. So the correct formula for chlorine gas specifically, is Cl2. Now we're going to write down our flow chart. Here's our flow chart. What are we starting off with? We are starting off with grams, which is a mass. And what are we going to end up with? Chlorine atoms. And that's way over on the other side. Is there a direct route? Can you go from mass to atoms in one step? The answer is absolutely not. So the first thing I'm going to do is I'm going to go from mass to moles. That's using the molar mass. Then from moles to molecules. That's Avogadro's number that I'm doing. And then from molecules to atoms. So let's step this out here and see if you can follow along. So the first thing I'm going to do is I'm going to have grams of chlorine, that's Cl2 to begin with. I'm going to have the molar mass of chlorine, Cl2. So I'm going to multiply the molar mass by 2 that's on the periodic table. Okay? And I'm going to have moles in the numerator. Then moles are in the denominator of my next term, and then Avogadro's number goes with molecules. Fantastic? In the denominator of the next term, I'm going to also have the molecules, but it's not going to be Avogadro's number. I can only use Avogadro's number one time in one flow chart in one monorail. So that means one molecule is equal to a certain number of counting atoms. And how many atoms are in Cl2? Do you see that formula, Cl2, right there? How many atoms of chlorine do you see there? 2. So for every one molecule, there are 2 atoms of chlorine. So I'm going to give you just a moment, pause the video, write it out on that stoichiometric monorail and see what you get, and then start that video again, and boom, and this is what you should get. You should see that the grams of chlorine cancel out. You should see that the molar mass of chlorine is 70.906. That's the 35.453 times 2. Then the moles are going to cancel out. Remember, the number in front of the mole is always a 1, because it's 1 mole is equal to the molar mass. 1 mole is equal to Avogadro's number. Then the molecules are going to cancel out. The moles and the molecules go together. 1 mole is equal to Avogadro's number of molecules, and then 1 molecule of any formula is equal to a certain number of counting atoms, and that's why that chlorine atoms is in the numerator. I'm going to look at number of significant figures. There are 2 significant figures because that 30 with a decimal place, that trailing 0 counts. Trailing zeros count with a decimal in the number. So that's 2 significant figures. That 1 in front of the mole has an infinite number of significant figures. As always, Avogadro's number, how I have it written down, has 4 significant figures. And 2 atoms, that's actually counting the atoms. So that is 2 atoms counting is an infinite number of significant figures. In the 70.906, the molar mass for chlorine, it has 3 decimals. I multiplied it by 2 because there are 2 counting atoms of chlorine, but that has 5 significant figures in that number. Then in the denominator, there's 1 mole of chlorine, and that 1 in front of the chlorine, that's a definition. That's an infinite number of significant figures. Then the 1 molecule is actually counting, or a definition, however you use it, and that's also an infinite number of significant figures. Then I'm going to multiply the 30 times 1 times Avogadro's number times 2 divided by the 70.906 divided by 1 mole divided by 1 molecule, and then I'm going to get the following number in my calculator. I'm going to round to the fewest number of significant figures, which is 2, so I'm rounding with this 9. So I'm going to add 1 to the preceding digit. That 0 is going to become a 1. And now I have number units formula, as I always do. It's 5.1 times 10 to the 23 atoms of chlorine. Okay, that was a long problem. We went all the way through those individual steps. You have to go through the whole entire flow chart. Notice that I have 1 monorail doing all the math. Okay, here we go. Here's a little bit of mole humor for you and a cool hat. Okay, what do you call a government in which a mole is in complete power for the duration of their life? That's right, it's a molarchy. Ha! Okay, so that was 4.4, and you're going to keep on watching these videos. You're going to rewatch the videos so that you know what you're doing. All right, I'll see you next time. Cheerio.